In order to set our parameters for the 6th Congressional District in Massachusetts, we need to do a series of calculations. The first of which is to look at the voter registration for people within the district. In order to get this data, you go to the Secretary of State page here in Massachusetts, go to the Elections Division. And within the Elections Division, there'll be a tab set Election Information. The last voter registration data that was provided in the state is from 2012. So if you open up this file, you'll see that voter registration by party, and then as it works across the different counties within the state. So here's Barnstable County. For our purposes, we'll be looking at Essex County, Amesbury, Andover, some of these towns, and Middlesex County, which are some of these towns. Then what we'll do is we'll go to an Excel sheet. And within our Excel sheet now, we have all of the cities that make up the district. One caveat is that Andover, as you see here, makes up a series of precincts, 1, 7A, 8, and 9A. So it's a little bit of a smaller, but when we look at the map, you'll understand how they've cut up Andover. So here we're going to put in total registered voters. Then we'll put in Democrats, Republicans, and Independents. So we'll go back to our database here. Let's take a look at, we'll start up in Essex. And looking at Essex, we have Amesbury, so it's 11203. We'll go to our data set here, Amesbury 11203. We'll go back, take a look at number of Democrats is 3,062. We'll come here, put in 3,062. We'll take a look at our Republicans, which is 1483. 1483. And then we'll take a look at our Independents. We skipped the Rainbow Party. It's a very small party. So just go with the independent number of 6567. And we'll put that in over here, 6567. I'll now do that for the remaining district. Now we're going to want to know what percentage of the vote makes up, or of registered voters make up the district. So there's 522,569. So in order to find out the percentage of registered voters, we can go with an insert here. We're going to take this number, 11, and divide it by here. And sometimes we have to reformat the cells. So just put in general, we'll reformat that. So now you can see here, copy these all the way down. And then take these. You can see what percentage, Andover is the caveat, because remember it's based on a couple of precincts. So we'll come back to that in a moment. Otherwise, these are the percentages used for each one of the regions or cities and towns. Then we're going to insert a couple of more cells here because we want to take a look at what the percentage of Democrats, Republicans, and unenrolleds are as well within each one of the towns. So before we do that, just copy these cells and then paste it as a value as the percentage. Otherwise, if you look before, it was a formula. Now that we've pasted it, it is a value. And then here we'll just take our number of Democrats and divide it by the total. Again, sometimes you have to reformat the cells. With Excel, sometimes they take on a life of its own, and it thinks it knows what you want. And normally it's pretty intuitive and right, but sometimes it is not. And so we just want to make sure that we have all of our data lined up. So we can take this now, so we know what the percentage of Democrats are within each one of the towns. We know the percentage now of registered Republicans in each one of the districts, and then we know the percentages of unenrolled voters in each one of the districts. We'll also take a look at one more number here, and we'll divide our overall Democrats by the county. So we know that by the district. So we know that 29%, almost 30% of the district is Democrat, and we know that about 13% of the district is Republican. 57% are independents. So now that we have this data, we'll go on to the next step. Let me just highlight this for us. Now we'll go back to our elections division. We're going to go to election results, and now we want to calculate the election results for the last two elections to be able to determine what the voter turnout has been in those elections. We're going to look at U.S. House races, and we're looking at the 2016, the 6th congressional. We're going to click OK, and now we can see here we have the general election that Tierney won last time against Tassay. You've got the Democratic and Republican primaries, and then the general election for 2010 along with the primaries. So we're concerned right now with the general election, not the primaries. So we can look here and see there was almost 390,000 votes last time, and you can see how it broke down. What we'll do is we will download this file as a municipality, and then we'll open that and we'll use that in a moment. In the meantime, we're going to go back to our last search and take a look at the 2010 race as well, and then we'll look at our details, and we'll study it in more detail once we've downloaded the data. So what we can do here is, here's our 10th congressional race. We can take a look at our total vote count divided by the total votes. So in 2010 there was 260,000 people that voted compared to 2012 when it was almost 390,000. So it goes to show that presidential elections you have a larger turnout. So now what we're going to do is divide the total vote by the total number of votes casted, and now we can begin to see what the percentage of the turnout was in each one of the districts, each one of the towns within the district. And we'll do the same here for the 2012 race as well, looking at the total votes casted, dividing that by our total, and pasting those in. Remember right now that these are values, formulas, so we want to turn them into values. So we're just going to copy and then paste special values, and so these become values. We'll do the same thing with the 2010 results. You see, these are now going to become our values. Paste, copy, paste. You can also go to paste special and then click in as paste values, and you can see those are now values. So what we're going to do here is take this data, and anytime we're going to manipulate it, it's always good to keep a fresh set. So right now I just care about the percentage that is coming out of the 2010, out of these towns, because remember the towns do get changed a little bit. We're going to go to 2012, and we are going to look at this data a little bit later as far as a battleground to see in what regions the votes are coming out of. So one thing that you can do at this point, and this is in 2012 because it's the same race, so you'll see similar results. Now we're going to take a quick look. We're just going to add up the Tassay-Tierney numbers within each district. We're going to reformat these cells so it's a general number. Copy that formula. We'll divide Tierney's percentage by that formula, and then we'll divide Tassay's percentage by that formula. We'll copy these cells, we'll paste them all the way down. We'll look at this later on once we've organized our data to be able to determine what we think the projected turnout vote count should be in each region once we've calculated that. So now that we've got, let's just label it, so Tierney, okay, and because now these have been all labeled, valued, we can put that in, and then this is percent turnout. So now what we're going to do is we're going to copy this, put it in a a new cell, and then we're going to get rid of these columns. We're just going to leave these ones in, and we're going to bring over from our other data, the 2010 race, the results here. Now remember that we've added and subtracted, or we've actually only added here within Massachusetts our congressional districts. So we can see that Andover has been added. So we want to push this one down because this is in 2012. In 2010 there was no 2010% turnout. And this is 2012% turnout. And so let's go through. You can see that we've also added Bill Ricca. So we've got to move these down, and then Bill Ricca. And then we've added Tewksbury, so we'll move these down. So the last group that we want to bring in will be the registered voters, but before we do that, we're just going to now project out. So now we're going to just take an easy calculation. We'll take our vote there, and we'll add it to the 2010. So now we'll get a total vote, and then we'll take this number and divide it by 2, and this is going to be the projected vote on our first pass through. One more way that I like to look at it is Andover. Because there was no second one, we like just to put that full number in. Same thing with Bill Ricca. Otherwise, we will be underrepresenting these towns because we'll be cutting their turnout from last time in half when we're not doing it anywhere else. You can see that we're a little over the 1%, the 100% mark, and that's because we've added in 3 towns into our data. But don't worry, that number will even itself out once we have finished doing all of our calculations and cutting our data. The next thing to take a look at is that raw data that we had put together regarding our party affiliation. So now we're going to take this data again, and we're going to copy this and then paste it into our 2012 data set that we have here. We're going to paste it down as a value. And so we just want to make sure that all the towns line up, and they do. And so now what we want is, this is our projected number 1. This will be our final projection, and what we'll take a look at is our number of registered voters within the district. And so we're going to do another calculation of just simply adding together our projected turnout by the total number of registered voters, and this will give us our 2010 turnout in 1 second. We just have to now take this number and divide it again by 2, and this will become our turnout number. So 2014 projection, and we can see that in Amesbury we're expecting about 2.2% of the vote. City like Rockport, we're expecting 1.2%. As compared to Peabody, we're expecting 7%. Lynn, we're expecting close to 9%. So as you want, you take a look at our other numbers that got us to this point, and you'll see that they should all be very similar. If something jumps off the page, you might want to reconsider taking a look at them, so to make sure that you haven't inputted the data improperly. So the next thing to do now is to take these cities and towns and turn them into regions. So this is when you take out your map of the district, and you can see where everybody lines up. Merrimack, Amesbury. So what you'll do is start putting them into regions based on this map. So if I come over here, we're going to put them into 3 regions. So I see Amesbury. I think that they belong in, we'll put it in here, region, and then we think Amesbury belongs in the north. Andover, as we can see in the map, is over in the west. So we can put them, we can either label them this way, or we can label them with a nominal measurement. So we could put north as a 1, west as a 2, and so we know what regions that they're in. For our sake today, we'll keep them on here, and we'll just go through and do. Now that we've put all of the regions in based on the mapping, we're going to sort by region, and this will give us our percentage that we should be looking for. If you go to data sort by region, it's right here. So we can see that in the north, 31.77% of the vote comes out of the north, 34.8% comes out of the south, and 36% come out of the, this is 31.77, out of the west. So this is the north, the south, and the west. So now what we'll do is when we put in our data field, we'll be able to put in all of our parameters. We'll also know that in 2012, we're expecting to say in this district, in the northern part, you're looking at he's roughly getting 47% of the vote. I mean, Tierney's getting roughly 47%. To say gets a higher average, but we'll talk about that later. Now it's time to open up our raw data that we have downloaded. And here is the raw data that we have. And what we'd like to do at this point is run a crosstab to determine what our significant variables are. Remember that chi-squares run on the assumption of randomness, and so that's what we'll run our analysis on. The first thing that we have to do is now code all of our cities and towns. So go through, and Amesbury is in the north, so that's a 1. Andover's in the west, so that's a 2. And go on through and code all of your towns. I will do that now, and then we'll change this to our region, and then we'll be able to run our first crosstab. Okay, now that all of the towns have been coded, what we're going to do is take all of our data, even people that didn't complete the whole survey, and the first thing we want to know is if there's a significant difference between voters and likely voters and other types of voters. So we're going to take all of our data and we put it in to SPSS, as you see here, and we're going to run a, give it a second, it's a large data file, sometimes it slows down, SPSS, and then we're going to run our chi-square on the crosstab. So we want to make sure that we have it all in. So you can see that's all of the people that completed the survey. And we'll go to descriptives and crosstabs. And now we want to crosstab our general ballot test with our likely voters. We'll go to statistics. We'll click on chi-square. Click continue. We go to cells. We click observed, expected. We can click on row if you'd like. Not necessary, but gives you something to look at. And the reason why we choose the general ballot test is because that's the key question. So we want to see if there's a difference between voters on that. And what we'll find here is that there is, on 6 degrees of freedom, Pearson chi-square is at 33.193. So in order to test for significance, we have to go and find our Pearson or chi-square distribution chart. We go at the 0.05 level, and we said 6 degrees of freedom, so 12.59. And what we found in our data was 33, so it is significant. What this means is that there is a difference between likely voters and other types of voters, somewhat likely, unlikely, and not likely. To the eyeball, you might not notice the significance of the difference, but that's why we run the chi-square. So what this tells us is that based on our turnout, which we're expecting to be a low turnout, that we should be looking at likely voters only. So we're going to cut our data in a moment to do that. What we also want to notice, though, is that if there's a higher turnout, maybe over 50%, then what we're looking at is Tierney will be doing better, because you can see that he does either equal or better within those areas, within those type of voters. So now we'll go back, and now we got our raw data back, and what we're going to look at is we have 472 people. So the first thing is I only want our likely voters. So we sort now, or we've already sorted, and so now we only have our 472. Remember before we had the 652 or so. So we'll put them, our 472 right here. What we're going to do now is run, we want to just make sure we take out a couple of other folks. And those are not our registered voters, so we're going to get rid of the number 4s. And now we're going to run our crosstabs again and take a look at which ones of these are significant. So we'll copy all of these and paste them into Excel. Before we go and put in our data, we're going to just actually sort by one more variable, and that was the time of the call. There was a Democratic state convention, and we want to see if Tierney got any sort of bounce. So the convention was on the 14th, or the Friday night, and then went into the 14th. So we're going to take a look at pre-convention, which would be the 12th and 13th, and then we'll compare that with our post-convention, which will be on the 14th and after. So now we'll take this data, paste it in. Now what we'll do is take our data and copy it and put it into SPSS. Again, we're keeping everybody in there for right now, in order for us to look at our and paste. And now we put in all of our data, and you can see all of our data has now been in. And we're going to run our chi-squares, looking at this set. So we'll take a look again at our ballot question, and then we'll compare that with our regions, ethnicity. Put them down there. We'll hit our statistics, chi-square, click continue, go to cells, observed. We'll look at the rows, not that you need to, but if they're there, why not? So let's take a look at ethnicity. 8 degrees of freedom. If you go back to your chi-square chart, you'll notice that the 8 degrees of freedom at the 0.05 level is 15.5, and here our values at 12.48. So we would say it's not a significant variable. Moving our way up, party, you can see that our degrees of freedom are 4, so it's 9.49. Here, party is a significant variable, so we'll have to control for party. Likely voters, we're only using likely voters because we're expecting a low voter turnout. And then we'll take a look at our age, and within our age category we have 6 degrees of freedom, and at the 0.5 is 12.59, so that one is significant. So we know that we want to control for our age distribution. Then what we'll take a look at is our gender. Gender is 2 degrees of freedom at the 0.05 level, and that's 5.99, and here we're at 18. So that one, gender, we want to control for. Convention, 2 degrees of freedom, and we're looking at 5.99. So here we would have a significant, somewhat very small significance in how people were voting pre-convention versus post-convention. You can see that before the convention it looked like Tierney had a small lead, but post-convention that changes. Our regional breakdown again is 4 degrees of freedom. If we take a look at our chart, regional is not a significant factor the way we've broken them up into regions. So knowing all of this, now we can go back and set our parameters. We're going to set our main 2 parameters at the gender and party affiliation, because those are the most significant, and then afterwards we'll weigh for ethnicity. We won't actually look at anything with the convention because that is an actual event that will have some influence. So we can say that Tierney got a slight bump out of the convention based on what he was polling before, and what he was polling after. So now we want to clean up our data, and we're going to eliminate anybody who had a unit non-response. So if you skipped a question, you'd be out. So we're going to now sort by our last question, which is ethnicity. And what we'll have here is 380 people. We'll get rid of the folks that, as you can see here, fell out of the survey as it was going. What we'll also take a look at is our time that the calls took. So we can sort by that number. What we'll put in here is a standard deviation formula. So we'll go to our, not auto sum, but more functions. Click OK. We go to ST standard deviation. And highlight that. And we have our 52.184. Get that by going into here, clicking on our standard deviation, clicking OK, going through all of our cells. So that's, as you can see here, that's the formula that we use. So what we can take a look at now is what's the average call time was 377 seconds. From here you could say if you wanted to take off 2 standard deviations, you would be eliminating 104 people from our survey to take us down to about 256. One thing to notice is that while the rules say to go 2 standard deviations, it's also a judgment test on the part of the researcher. And you can see here that these folks all took over 4 minutes to complete the survey. So while they might be finished quickly, it is something that we should keep in mind and take a look for to see if there is a consistent trend of numbers. And you can see here that these folks, they certainly did, certainly appears that they just kind of answered 3 across. You can see there the 1s across. But starting about here, you can see the variety in the numbers. So as the pollster, I would probably cut them at the 258 mark and leave everybody else in the data set. There's proper, it appears proper look. And so while the rule is that you would move your standard deviations here, you can see now that the standard deviation has been decreased. We're down to 374 people, and we would go down. So I would feel comfortable here knowing that somebody took over 4.5 minutes almost to complete the survey. So the next thing to do is, so now that we've cut our data, we put the new data in, and we have 374 people. We're going to run a quick crosstab with gender as our row, party as our column. We don't need anything over here. And now we'll be able to look at just what we have within our party and gender. Those are the 2 most significant variables that we need to control for. So we'll go back to our raw data, and we'll set up our fresh page. And we also know that we've already taken some of the data that we needed, and we will put that on that page as well. So this is what our party looks like, and as far as what we have available to us, and this is what our demographics should look like. So because we're going statewide, we really district-wide, because regions aren't important, we can get rid or not significant, we can get rid of these folks. Now when we take a look at our genders, we know that amongst Dems they need to hit a certain number, Republicans we have another number, and others we have this number. This number I gave to you, these are the generic gender breakdowns. If you were working on a campaign, you would have a voter list and be able to put together your genders, but because you're not working on the campaign, the best data that you would have available is a gender breakdown, probably by the US Census, but they don't necessarily do it by party. So you would look at some other surveys to find out what the typical distribution is by party and gender. So now what we'll do is we'll take a look to see what percentage of the sample we need. So we know that we have within our Republicans, Democrats, and Independents. So within our Republicans, it's 84 people. Within our Democrats, it's 105. And with our Independents, it's 185. This adds up to 374. And we'll put it right there. And so we can see that Republicans should only make up 13% of the district. Democrats should make up 30%. And Independents should make up 57%. So we're a little shy in the Independents and Democrats and a little heavy amongst Republicans. So now we're going to have to decide where we're going to cut this data. Well, let's take a look to see what we have here. We know that within our Democrats, we only have 35 males and 70 females. So that might be our low point at 35. Also, Independents, we have 81 and 700 and 104. So that 81 might be our low point as well. So we'll take a look at both and decide where we're going to end up with our sample. So now what we'll do is we'll take our Democrats, and we know that we have 35 males. So if we put 35 here, we could do a simple calculation and just take equals 35 divided by 46. And so this would give us a sample size here of 76 people. So if we had 76 Democrats, we just do equals 76 times, that tells us we need 35 males. And if we do 76 times this, we know that we have 41 females. So we know we have those numbers. So when we do our stratified proportional sampling, we'll be able to hit those marks. So now we have to decide, using this as our frame of reference, how it is that we're going to calculate the rest of our numbers. So we know that we have 76, and we know that they should equal 30%. So if you do 76 divided by 0.3, we know that our new sample size should be 253 people. So that we have our sample size of 253, and this is 0.3%. We know these folks, the Republicans, should be only 13%. So we'll just do 0.13 times our new sample size, and that gives us 33 Republicans that we need. And then amongst the Independents, it is 0.57. So we go equal times 0.57. So we know we need 144. So here we can put down our 33, and here's our 144. Now what we'll do is we'll take an equal 33 times our males, and then we'll do the same thing 33 times our females, and we'll get roughly 17 and 16 there. And then we'll do the same thing with our other independent category. We know we need 69 males, and we'll do this number, and 75 females. We'll look here. We know that we have enough males and enough females. So now it's time to cut our data one more time. We'll go back to our data set right here, and this is our 374 folks. We're going to copy the whole thing and put it on a new sheet, because anytime we cut, we always want to be duplicating it in case we make a mistake. So now we're going to highlight the two columns that we're going to be looking at, and that is our gender and our party. So we're going to sort now by party. We're going to add a level, and we're going to sort by gender, and then we're going to add one more level, and we're going to sort by the call start time. And the call start time, like what we did before, will allow us to do the first in, last in, first out within each one of the parties, within each one of the demographics that we're controlling for. So here's our first group. The 1 stands for Republican, for female, and the 1 here stands for Republican. So amongst, we'll go back to our data set right here. So amongst Republicans, I need 17 males and 16 females. So now you'll go back to your data, and we've already sorted, so we need 16 females, and we have 39. So what we're going to do is take out 23, and that should give us 16 females, and we need 17 males. So we've got 45, so we're going to take out 28. We'll go back and take a look at our our distribution table that we've created, and now we'll take a look at our Democrats. Democrats, we need 35 males and 41 females. So we'll go back, and now we'll take a look. These are our Democrats, these are our females. We need 41, and how many do we have? We have 70, so we're going to take out 29 of these folks. Now we need 35 Republicans, and this was our low group, so we should find 35 Republicans, so we don't have to do any more cutting there. And then we'll go to our last group, which is the independents. We need 75 females and 69 males. So now we'll come over here to our data set again, and these are our females. We need 75, and we have 103, so we're going to take out 28, and then we need 69 males, and we have 81, so we're going to take out 12. I just want to double check our female category. We needed 75, and we have 76. I thought we left one guy in there, or one woman in there, so we'll take them out. It would be a woman. That's what we're cutting for. Alright, so now we've cut our data. We can now take it, highlight it, and copy and paste it into our SPSS. Okay, so we've just pasted in our data, and it's our 254 people. And now we can run our frequencies. So we take all of our data, we put them in, click OK, and we can see that in our frequencies how they round out. We have a nice distribution amongst the convention. Our population is accurate. We're only using likely voters. Our demographics regarding party is accurate, and we'll take a look at our favorability questions, the primary, and then of course the most important one to the voter or to the public is the general ballot test question, and you can see here that to say holds roughly a 5-point lead. After you do that, you'll run your crosstabs. We'll go down on our crosstabs. We're going to reset this, and usually you run all your crosstabs. So you put your region in your row, you take the rest of your variables, put them in your column, click cells. We click percentage in rows, click continue, we click OK, and here are all of the regions cross-tabbed with all of our questions. We can look at it again. We'll do our cross-tabs. We reset, put in our convention, and then run it with all of the other variables. Click cells, we click row, click continue, click OK, and now we run those. You would do that for the rest of the crosstabs. If instead of running crosstabs, you could also run tables. And tables are, you take all of your variables on this side, and we put them up by our rows and our columns. Then what we do is you go into your row, you click on summary statistics. We'd like to put in our, we put in our row number, and we applied it to all of our sections. Within our regions, we have to do these individually. We'd go to our categories and click on total, and then we apply that to all of our sections. Then you click continue, and it runs all of your tables for you right here, which are essentially your crosstabs. Then we'll go to File, time to export our data for us to analyze, and we're going to call this one Part 2. And as you can see, we're using the newest version of Excel because we have a large data set. The newer versions allow us to keep that data set going. Once we've done that, it's time for us to clean up our data. So as it exports, we'll give that a second, then we'll open it up in Excel. Okay, we've opened up the data set, and we're just going to clean all of this up. These are previous tests that we ran, and we're just going to get right down to our frequencies that we're interested in right now. So that's the end. So those are our crosstabs, those are our frequencies, and everything above here will be eliminated. And the key here is just to clean this up so it's easy to read and analyze. So within our frequencies, we'll leave those there, and then what we'll take out is this data isn't necessary. Take out this data here, and we will just run all of our crosstabs. So you're either going to keep your crosstabs on a separate page or your tables. So here we're just putting our crosstabs here. We'll delete that, and then we'll clean this up. We'll take our tables, and we'll move those over into another tab as well. Normally you would only have two tabs, one with crosstabs, and one with frequencies. You always have your frequencies, and then this would be your crosstabs, and this would be your tables. And when you do your tables, one way to clean them up is you take your header row, and then we can just insert it. So it's a little bit easier for people to read, and you'd go and do this throughout the page. And that way, as you're looking at each one of your demographics, you can control for that. Within our crosstabs, you would just read them as you would, and then, if necessary, come over here and delete these. And as you can see here, where it's time to analyze the data. So you start with your frequencies, and if you have it all cleaned up, you can bring this all together. Sometimes what you do is you just click on page layout or formats, and we go with auto row width, and that will clean that up. And so we can start to look at overall, what did we find? We know that the key variables was gender and party. We know that Tierney was gaining after the post-convention. He got a little bit of a bounce. We can see that here we'll just take a look at one crosstab here. Convention, pre and post. So before the convention, he had a 32% favorable, 52% unfavorable. After the convention, his favorability goes up. So the rah-rah spirit of the convention looks like there might have been a bounce from that. And then what we'll take a look at is in the general ballot test, Tierney is getting blown out by Tassay early on, but after the convention is much more competitive. So you can say that the momentum up here has shifted back to Tierney. You can also find that data here within our tables. And here what you would do is you would view, you would freeze these panes over here, and that way what we can do is move over our ballot test. So it doesn't matter which way that you run, if you run it as a table or a crosstab, the data should be the same. So you can see that before the convention, Tassay was much stronger than after the convention. So it looks like the Democrats were able to rally the base at the convention and give him a little bit of momentum coming out of it into the summer. So continue on, do your And you can see that this says misspelled, so you would want to make sure to go in and clean up your data anytime you see a misspelling before you would turn that in, of course. And take your time and go through, and you can see all of our different tests that we can run. Again, crosstabs are just fine. Whatever you run, just make sure that you clean it up, and we can go from there. Please email or post any questions that you have about this.